Jason, what is y2? What was that again? F of a plus h. y2 minus y1, Isaac. F of a minus h. And then the denominator, we'll say it, and then we'll simplify it after. So x2, a plus h, minus x1, which is this guy. You're going to distribute your negative, so you'd have a minus a. Then you'd have h minus negative h, which gives us 2h. That's the third one. That's called the symmetric difference. So these two use a point and the 1 point far away. So here's a, and that's h. So it just says that h has to get smaller, so we'll go towards a. The second one, here's a, and they call this one x, and then they make x go towards h. This one is a little bit different. So this one, there's a, but there's a point to the left and a point to the right. The point to the left is a minus h, and the point to the right is a plus h, and they both go towards a from both sides. So that's why they call it a symmetric difference. This last one you don't see that often. They really do test the first two, but I have seen test questions that just write up. They literally will write the slope formula with a limit in front and then just ask you which ones could you use to define the derivative. I've seen that question. So you have to understand that the derivative is a limit where you're taking 2 points and making them get closer together. That's literally the definition. All right, moving on. So that would be a problem that's familiar. This is the type that you've seen. This is how they're going to test the difference quotient. They're not going to ask you to do the difference quotient. They're not going to tell you to do the difference quotient. They will give you a problem where you have to identify that it is the difference quotient and then use the definition. I would like you to do this problem because we have done this similar problem multiple times. So you have to identify the fact that it was the difference quotient. My first question is actually, what's the question? And no, I don't want you to read me the limit as h goes to 0 of 8 times. What is the actual question they're asking? What is the slope at a value? So that's the definition, right? So you can check your work. I am going to go through the steps that I think are always the best way to do these. First, find your h, and there's going to be a plus number next to it, always, every single time. That's this number, a. You're going to identify the a first. Do not use the f of a piece, because sometimes it gets simplified, and then you don't know what it looks like anymore. What do I mean by that? What if the function was tangent of x, and then they decide to do at pi over 4? You're not going to see tangent of pi over 4. They're going to simplify it to 1. So don't use the f of a, use f of a plus h. So first thing you want to identify, that's your a value. So your a value for this problem is 1/2. Second piece you want to identify is what was the actual function. Then you're going to take the whole entire a plus h, that piece, that yellow bubble. What are you going to replace that with? An x. So that's how you identify what the actual function was. So in this case, f of x was 8, and we're going to replace that yellow bubble with an x to the 8th. Therefore, the question asks you to take its derivative. Notice some of you guys couldn't do that anymore. Double check your papers. Going down to power after multiplying, right? And then you're doing 64 times 1 over 2 to the 7th. It's easiest if you try to simplify. 32 is to the 5th power, so this is to the 6th power. I think it's 1/2 then, huh? 32 is 5th power. I don't know why I know that. 64 is the 6th power, so it must be 1/2. You do not have to do the problem by simplifying this guy because you can't. It would take you forever. Because if you wanted to simplify it, which is the other way to do the problem, what would you have to do that would take you forever? FOIL. How many times? 8 times. That's why we don't do that method. Okay? That's why we don't do it. Also, if they give you trig, I don't reteach sum and difference in here for a reason. You don't need it. You can get through the AP exam without the sum and difference formulas for trig. So when you see these with a tangent, you actually can't do them without the sum and difference formulas, which is why we don't do it that way. We do it using the definition of a derivative. Okay? Good there? All right, last little piece, differentiability. I got to get through this pretty quickly. Differentiability, let's go back to the table we had. F of x can either be continuous, and you can actually continue it on your other one if you want, or it might not be continuous. I'm going to abbreviate. You have the removable, the jump, the infinite, I'm just rewriting, and the oscillating. So those are the ones that we already studied. What do we know 100% has to be true? If you're not continuous, then not differentiable. The derivative at all of those, f prime of a, is undefined or does not exist. Either of the two, doesn't matter. Okay? Infinites, you guys always think of like x to the 1/3. The other thing about infinites, you see them graphically? Semicircles. Semicircles have vertical tangents. Oh, whoa, wrong thing. That's not what I'm talking about. Getting ahead of me. Got ahead of myself.
Senior courtyard will also be open for seniors only. Students, we do not want you hanging out or eating in the front of the building. All the academic hallways are off limits for eating. That's at all 3 levels. That's E, F, and G.
So, these are your 3 non-differentiable points. But the special thing about those, they happen to also be continuous. Whereas, if you have a removable, a jump, an infinite, they're not continuous. They also don't have a derivative. I want to just really quickly, before you guys go, I want to go through those and just make sure you remember your rules for those. So, a corner. Easy one to think about. Maybe not. A corner is something like absolute value. A corner is any time you have a piecewise where one function connects to another function, but their slopes won't be the same. So that would be a corner. A cusp. Glad to know that you guys don't remember any of it. Even over odd, where your power, I'm going to just rewrite it this way. Your power has to be between 0 and 1. So please give me 1 power that would give you a cusp. 2 over 3. 2/3 is our easy one that most of you remember. And then third thing, f of x equals odd over odd, but same rule, where the odd over odd, the power, has to be between 0 and 1. What's one that you remember? 1/3. And then I just mentioned vertical tangents also happen with semicircles at the, I guess, the corners of the diameter. Those are vertical tangents. That happens a lot in graphs. Graphical free response questions, they like to use the semicircle for that reason. Last question that I gave in the other class, and I will go to your question, is find me where the non-differentiable points are and give me the domain for this function. So the domain, and not differentiable at. Yeah. Uh-huh. Uh-huh. All right. Oops. So I'll just say it. This was the odd root. So odd roots have a domain of all real numbers, and then not differentiable. We only care about the transformations on x, and that's this piece right here. So we set it equal to 0, and those will be your non-differentiable points. So this is a continuous function, but not differentiable function.